8.7 is solving for a side, like we did on the last lesson, but now you're going to have triangles that are conjoined or put together, and you have to figure out the order to make your proportion. So number 1 says in the diagram below, GH is parallel to DE. So these lines are parallel, which is important. If FH, so this segment here is 2, FE, so I'm going to do curly bracket here to show you this whole distance is 3. GF, so here to here is 4. Find the length of DF. Okay, so what I want you to be able to see is that this smaller triangle, if I were to remove it, it would look something like this, correct? And then the big triangle, if I were to just write it by itself, it's not going to be perfect, but would be something like this. So if they were separate, I bet you could make a proportion. Oh, I should have wrote 3 here. Sorry. This one was 3. So I could say that 3 is to 2 or 2 is to 3 as 4 is to x. But what I want you to do is not have to separate them every time by hand, but actually look at your picture and know that this smaller triangle is similar to the triangle it's inside of. And so I'm thinking, here's this side, short side, to the whole side of the big triangle is 3. So 2 to 3. And then here's my hypotenuse of my smaller triangle is 4 to the hypotenuse of the whole triangle. We're not really using this little section here because that's not a triangle. And that's all you're doing. So 3 times 4 would be 12. Divided by 2 would mean x is 6, but it wants the length of DF. Yeah, okay, 6. That's what we found it. Okay, number 2, call these a bow tie. Kind of looks like a bow tie. It's almost like they've been twisted because you see here that this line is parallel to this line. I just marked over my 7. So let's just, I'm going to extend those out a little bit. So if I'm going to make this line here be my transversal, this angle and this angle would be my alternate interiors. So if these are congruent, you're looking at this angle and this angle. It's like if I flipped this one over, reflected it so that that point was here, it would be in the same orientation. So the way I think about it is that this side correlates to this side. This side across from my angle I knew is congruent correlates to or corresponds to this one that's across from my angle. So I'm going to say 4 is to 5.6. And I went from this smaller triangle here. So I have to go x is to 8.4. So again, I started here. You can start wherever you want, 4, and then I know these two sides are actually going to be corresponding because this has been twisted. And then I went x is to 8.4. And then we're just going to cross, multiply, divide. So x would be 6. Right, and then number 3 is a trapezoid. It tells me that OP is parallel to LM. So I just extend them a little bit just so you can see a little bit better of our transversal. If ON is 10, LM is 24, NM is 18, and OP is 20. Find the length of LN. Okay, so I'm going to extend this line out. And I'm going to mark this angle congruent to this angle. Okay, the hard thing to see without just making it, let me get a highlighter. Your triangles are here and here. So you're kind of blocking out everything else except for those triangles, and you're trying to make a proportion. So I can see that this side here of 10, from N to my angle, into my angle, these two should be corresponding. So I'm going to say 10 is to x as, and then these should be like a 90. I'm just going to call them a 90. Across from here is my 20, and across from here is my 24. So I'm actually not using the 18 at all because I didn't know what this was. So I'm doing 10 is to x as 20 is to 24. And so that would be 240 equals 20x divided by 20. 24 divided by 2 would be 12. And ln, yeah, that's what we're finding. So ln is 12. So it's all about kind of in your mind trying to find the pattern to make your proportion.